Good day. In this video, we will be presenting experiment 3. In this experiment, we will try to control the LED output using Timer0, delay using polling and interrupt. The objectives of this experiment is to demonstrate how to create delay using delay polling and to demonstrate how to create delay using interrupt. Timer0 is divided into two parts. Timer0 delay using polling. Most microcontrollers includes hardware timers, which may be used as a time foundation for a variety of tasks. This project uses interrupt polling to explain how to utilize a timer to generate a delay for a flashing light emitting diode or LED. The second is Timer0 delay sewing interrupt. In most PIC devices, the Timer0 module is an 8-bit timer or counter. When Timer0 overflows, it can also cause an interruption. Based on Timer0 interruption delay, this project will make a flashing light emitting diode or LED. We will be using MPLAB IDE program for this experiment. To start the task, click File, New Project, Microchip Embedded, then click Standalone Project. After that, click Next, select the microchip which is PIC 16F18875 microcontroller. Use XC8 compiler. Lastly, save it to your preferred folder and save. In this project, we will be using three peripherals: system module, interrupt module, and pin module. The system module, the interrupt module, and the pin module will all be automatically included when you launch the MCC. Open the pin manager, then click on the RA7 output blue lock symbol, which is connected to the D7 LED. Once selected, it should turn green. On the pin module selection in the project resources section, the center screen should show RA7 listed on the I/O chart. Click on the output box to break the pin and output, and make sure an analog and WPU are not checked. Change the pin name to D5_LED to make it easier to understand in the code. Under the system module, select the HFINTOSC from the oscillator select drop-down menu box. Then, for the HF internal clock, select 4 MHz. Select a clock divider value of 4. This will enable the internal 1 MHz internal oscillator as the system clock. Check the low voltage programming enable mode. Click on the TMR0 label under project resources to make the Timer0 setup appear. Check the enable timer box and select the 1:256 prescaler selection from the drop-down menu. Click on the clock source and select FOSC/4. This will select the instruction clock as the clock input to the Timer0. Number 3. Type 250 into period box and it will change to the exact value of the 249.856 milliseconds. This is the closest the setup can get to 250 milliseconds delay. This will set the Timer0 to overflow every 250 milliseconds. After fixing the pin module, pin configuration, system module, and the timer settings, we will now proceed to the main C file. To access the main C file, first, click into the projects, then select source file. After that, click the main C file. We will now input the code that we have come up to this experiment. After implementing this code, we will now build the project. After successfully building the project with the help of the Timer0, we will now transfer it to the MPLAB IPE. First, connect the PKit3 to your computer using a USB port. After that, go to the advanced mode of the MPLAB IPE. To access that, go to Settings, click Advanced Mode, then type the password. To power on the PKit3, go to Power, set the voltage to 3.125, then always enable the power target circuit from the PKit3. After connecting the PKit3 to the computer and to the microchip, we can now program the PIC 16F18875. This is the outcome of our project. So
So this is experiment 3 using Timer0, delay using polling and interrupt. In the first part of it, we have obtained that the LED light will blink for 250 milliseconds. Right now we have modified the Timer0 and make it 2 seconds interval, and now we have achieved in this experiment the 2 seconds interval. For the third part of experiment 3, using delay and interrupt, we have now achieved blinking LED with 250 milliseconds interval. Now we will modify the code and make it delay interrupt with 2 seconds interval. This is the last part of experiment 3. We have now achieved delay interrupt for a 2 second delay for the LED light. In the first part of the experiment, we have used delay and polling, and for the last part of the experiment, we have used delay and interrupt. So in conclusion, we can achieve both delays using polling and interrupt. So this in this part I will show you that the LED is now blinking 2 seconds. It has a delay of 2 seconds.